Chapter 10, number 17. A discus thrower starts from rest and begins to rotate with a constant acceleration of 2.2 radians per second squared. How many revolutions does it take for the discus thrower's angular speed to reach 6.3 radians per second, and how much time does it take? So we start with theta equals 0, and we end up with theta equals theta f, which is how many revs, at t equals tf, which is how many seconds. That's what we're looking for here. So at first, what we have is an angular acceleration and angular speeds, because it was at rest, that's the speed of 0 at the start, and it's at this, and we want a distance. So for part A, we don't want a time, and therefore we should use the formula that doesn't have a time in it. So if you remember way back from chapter 2, or its equivalent here, what we could end up with is omega final squared equals omega initial squared plus twice the acceleration times the change in distance. It's just the angular form of that. And we want delta theta. So we solve this for delta theta, and we say delta theta is omega f squared minus omega 0 squared over 2 alpha, which is 6.3 rad per second quantity squared minus 0 rad per second quantity squared over twice 2.2 rad per second squared. And we end up with 9.02 radians. Sadly, that's not actually what they wanted. They wanted in revolutions. So we say 9.02 radians, and every revolution is 2 pi radians, so we get 1.4 revolutions. For part B, we have several different ways of doing it. I think the easiest way to do it is to remember that alpha is defined as delta omega over delta t. So delta t is going to be delta omega over alpha. So delta t is going to be 6.3 rads per sec minus 0 rads per sec, all over 2.2 radians per second squared. Notice that the units all work out nicely, and we get 2.8636 seconds. But with our only 2 sig figs, this ends up being 2.9 seconds. You could also go through now. You have delta t. You have delta theta from before. We could use theta equals 1/2 alpha t squared and get basically the same answer. But this is fine.